Hello students, Mrs. Moon here, and today we're going to do a tutorial all about like terms. So first of all, we have to define what does it mean for terms to be like terms. Like terms have the same variable and they have the same exponent. So they have to meet those two criteria. Terms with the same variable and the same exponent are considered like terms. So let's look at some examples and then some non-examples of like terms. So the term 7x and negative 3x, those are like terms. They have the same variable x, and the exponent, we don't really see an exponent, but it's assumed to be 1 if it's not there. So they do have the same exponent. Let's look at our second example. 12ab and 27ab. They both have the variables a, b. So this is an example of like terms. Looking here, x squared and 5x squared. They have the same variable x and the same exponent of 2. 6 and 100. Those are considered like terms. Yesterday we talked about in our tutorial that these particular terms are called constant terms. Constant terms are considered like terms. They do not have a variable at all. And again, we don't have any kind of an exponent because these are just constant terms. They are like terms though. Okay, here's a couple of non-examples of like terms. If we have 2xy and 5y. Now they both have a y, but they don't both have an x. So these are not like terms. Looking at the next non-example, we have 6x squared y and negative 2xy squared. They both have x, they both have y. They both have an exponent of 2. But you have to look at where the exponent of 2 is. Here, the exponent of 2 is on x. Here, the exponent of 2 is on y. So these do not qualify as like terms. So now that we've seen some examples and some non-examples of like terms, let's look at what kind of math we can perform when we have like terms. So our instructions on our problems today are to simplify each expression. It doesn't say anything about like terms in the directions. It just says to simplify each expression. So we have to know that the rule when we simplify like terms is to combine like terms using addition or subtraction. So let's look at problem 1. In problem 1, we have 3x plus 7x. These have the same variable x and the same exponent, which is assumed to be 1. So that means we can combine the coefficients. 3 plus 7 equals 10. And when we're combining like terms, something important to note is that we do not change the variable. We do not change the power. We keep that like term x. Sometimes I like to say we're going to keep the same last name. Okay, so 3x added to 7x gives us 10x. All right, let's look at number 2. Let's find our like terms. We have 10b and we have minus 8b. Those are like terms. We also have a plus 6. 6 is a constant term. It's the only constant term here. We do not have anything to combine with the 6. We are only going to combine the like terms, or the terms with the same last name. 10b minus 8b is 2b, but then we still have this plus 6 that we are going to keep in our answer. So our final answer here is 2b plus 6. The first one should have boxed already, was 10x. All right, let's take a look at number 3. Again, we're looking for like terms. 4x plus 7y. I see two different variables. Those are not like terms. Minus 2x plus 8y minus y. something that we like to do sometimes is to use some sort of a symbol to mark each of the like terms. So what I like to use are underlines. So for x's, I'm going to underline one time. 4x and minus 2x. And I want you to notice that I also underline the sign that came in front of it. That means I'm going to be subtracting, or I'm combining 4 and negative 2. So 4x minus 2x combines to be how many x's? 2x. Then I'm going to combine the y terms. I'm going to underline those twice. So I've got positive 7y and positive 8y and minus y. Let's look at two at a time. 7 plus 8. That combines to be 15. 7 and 8 add to be 15. And what about this minus y? Do I just take the y off and leave it as 15? And leave out the y? Does it just take away the y? No. We assume a coefficient of 1 when we don't see it. So we can say this is the same thing as subtracting 1y. So I get 7 plus 8, which is 15, and 15 minus 1, which is positive 14y. So this simplifies to be 2x plus 14y. Let's look at example 4. 16ab plus 9c squared plus 12ba. Do any of the last names look the same? There is actually one pair of like terms here. We know that multiplication follows the commutative property. The commutative property says it does not matter the order in which you multiply two factors. The product will be the same. So I need you to understand that AB is equal to BA. A times B is the same thing as B times A. So 16AB plus 12BA are like terms. 16 plus 12 is 28. We would rather write these terms in alphabetical order. So I'm going to write that as AB. But this 9c squared did not have a like term, so I'm just going to be bringing that term down. And this is our simplified result. That one was kind of tricky. You might put a star beside it. Those are like terms because of the commutative property of multiplication. All right, looking at number 5. This one's probably the most difficult one. I see some parentheses. So you should have learned way back when, maybe in about the 3rd grade, that when you have a number directly in front of parentheses, we are going to multiply that number by everything, every term inside those parentheses. So the first thing we're going to do to simplify here, before we try to combine any like terms, we're going to simplify our parentheses using the distributive property. So I'm going to bring down 8x. I'm not doing anything with that yet. I'm going to take this 4 and distribute it. So what is 4 times 2x? It is 8x. Then I'm going to distribute the 4 to the 3. What is 4 times 3? It is positive 12. Then I'm going to bring down the rest of this expression that's after the parentheses. I don't distribute the 4 here because minus x was not in the parentheses. So minus x minus 6. Okay. Now that my parentheses are removed, I can look for like terms that can be combined. So let's take a look at the x's. We're looking for the same last name, remember? So we have 8x plus 8x minus x. And remember, we can put a 1 here. So 8x plus 8x is 16x, and 16x minus 1x is 15x. Okay, so all my x's combine to be 15x. Then I've got this constant term 12. It combines with my other constant term, minus 6. 12 minus 6 is positive 6. So my entire expression simplifies to be 15x plus 6. I hope this tutorial helps you to understand what it means to be like terms. Again, to be like terms, we have to have the same variable and the same exponent. And what can we do with like terms? We can combine like terms. Good luck with your assignment. See ya!